In this video series, we are going to investigate another form of electromagnetic wave, which is commonly called microwave. By doing so, hopefully we can get better understanding on the nature of electromagnetic wave. A huge advantage of using microwave compared to visible light is its wavelength, which is in the order of a few centimeters, which makes it convenient to manipulate. Variables obscured by the small scale of optical experiments can be easily observed and manipulated. Here is the setup of the first experiment. On the left side is a microwave transmitter. I put a white mark on top of the horns to indicate orientation of electric field oscillation. The horn's function is to focus the microwave to a specific direction. You can see a GaN diode as the main component of the microwave transmitter, and its orientation defines the orientation of electric field oscillation. The device we use here has a facility to modulate the amplitude of the microwave, which makes it applicable to use for telecommunication. But for now, we are not going to use it yet. Now let's take a look at the receiver. It also has a horn identical to the transmitter. The main component of the microwave receiver is a Schottky diode, which responds to the microwave with a line axis by producing a DC voltage corresponding to the magnitude of the signal. Voltage produced by Schottky diode eventually drives an indicator on the back side of the receiver. This receiver doesn't need external power, since the microwave from the transmitter would have enough power to drive the needle of the indicator. Now let's start the experiment when the transmitter and receiver are aligned. When the transmitter is powered on, the receiver's needle moves to the right, indicating the amplitude of the signal received. When the receiver is moved aside, the indicator shows decrease of the amplitude depending on the angle between direction of transmitter and receiver. This effect is symmetrical between the left and the right side. Now let's see the effect of the distance between transmitter and receiver to the measured amplitude. At close range, the indicator shows very strong signal well beyond its scale. For comparison, the floor tiles are squares with 40 cm side. As we move the receiver away from the transmitter, the amplitude of the signal decreases.